Hi everyone, I'm Dariusz Rumiński. If you used to work on GitHub, you may know me as Keradus. I created a PHP CS Fixer project. Not sure if anyone here use it. Okay, some of us, cool. Basically, it's one of the static code analysis projects we have for PHP. The first one that offered automated fixing and not only linting. So we can run the tool on given code base, and without supervision, it will adjust the code to follow given style, given principles. We don't need to watch over it, how it works. We don't need to manually fix anything. It does everything for us. Side effect of that is we can run it as dry run, in dry run mode, so it would only lint the project you wanna work with. But here I wanna give you some thoughts, some ideas we learned while working on PHP CS Fixer project over last 5 years, which we basically called AutoReview. So what is AutoReview and why we would like to have it, why we would like to share the knowledge, spread the idea. Basically, with bigger projects, it's hard to review pull requests. Which means we get more and more pull requests. We need to spend more time reviewing it. As the code getting more complex, the code base it's bigger, it's heavier. It's super easy to overlook something. It's hard to remember about every single small details we would like to maintain. So we would like to automate this. That's why AutoReview. Also, it will allow us to save time, especially on the core contributors, on the maintainers, on the people who work with the code base every single day. The bonus point for why is that people like contributors, especially new people, new joiners in companies, in teams, tend to not like the criticism if it's given by other person. Like if somebody writes a pull request and I would ask him, hey, do it differently. Hello? Yeah. He doesn't know why, so we teach him. He does the same issue second time, third time, fourth time. We always come to him, we always try to teach him, but ultimately we get out of our, let's say, maybe control, like we're getting bored explaining it, why we should follow given rule, why you should follow given principle. And then we just say, hey, do it differently. The person doesn't understand why, he gets frustrated. If you automate this, it's not only save our time, but it allows us to also automate reasoning, why it should be done differently. And then, of course, this will not replace the manual review process. The aim of this is to make it easier, is to make it faster, is to make it less absorbing, and to finally allow the core contributor, the maintainer, the owner of code base, to focus on their logic and not on the details. So, what exactly we can automate? We can, we can check the project in environment. So how it works in different environments. We can check the configuration of our project. Is it following our principle? Is it good for us? And then finally we can check the code as well. So what we have normally? Normally, hopefully, for properly configured project, we already have automated tests, maybe with PHP unit, we have some linters, and then perfect scenario, we have static code analysis, for example, CS Fixer. What we can do more? What we can have more? Basically everything that we need to check manually. If we need to check some in the time, can we check the batteries? Hey, yes. Okay. So basically, if you need to check something manually over and over again, it's a good place to automate. If we ask for something in code review, doesn't matter if the same contributor on different people, if we ask for something more than once, it means that it's nice candidates to automate it. And finally, if even we, as creators, as owners, tend to forget about small details, we can also automate it just for us. Not necessarily for every single contributor, but also for us. So here, I will show 10 lessons we learned in CS Fixer over the last 5 years. Lesson first. We should target all environments. For example, if given version of our application is working on multiple PHP engines, we should test every single one of them. For example, from version 5.6 through version 7 to 7.4. Only then we actually know that we not just promising it works on, let's say, PHP 5, but we're actually ensuring it. But the environment is not only PHP engine or maybe some service level, service version like MySQL, whatever. Another example is good practices for PHP unit, which is a matrix of PHP version itself and the PHP unit we are using. So we have 5 different PHP version, 40 different PHP unit version, and then we have matrix of what we are testing on what. A lot of tests to ensure that actually our tool works properly on every single environment we promise to work on. Here for each PHP version we are running tests for given PHP unit version, and our small shell script basically try to install PHP unit version on the fly and then try to run the tests. Lesson 2. It's not only about environment, it's also about our ecosystem. If we have dependencies that we claim we support, let's say, some Symfony component or Drupal version, not pinned to one concrete version, but a given range. For example, version 3 and 4. By default, we will always install the newest version. So if we claim we support also some lower versions, we should test them as well. So here we have 2 commands. One command is ensuring that the composer will install dependencies for lowest possible platform we support, whatever it is for us. And then for given lowest platform, we also install lowest dependencies. By the way, every single lesson here we learn by, let's call it an emergency, bug in production. Somebody raised it, we didn't knew how to test it before. Somebody raised, we automate how to detect that for future. Lesson 3. We don't want to depend on deprecated features, especially for long-living projects, regardless its application or library. If it runs for years, like PHP CS Fixer 7 years so far, we don't want to bring more code, we don't want to accept new features for our project that are depending on some deprecated functionality of our dependencies. So for that, we can automate detecting that. So we basically forbid any contributor to write tests using some legacy functionality. We can automate it with Symfony PHP unit bridge, which will basically, after test execution, give us the warning, which will also fail the PHP unit itself, that hey, you are using some deprecated functionality, you can change it with a new version of it. Next lesson. Again, for long-living projects, we don't only want to not use deprecations, but we also want to be future ready. Especially for new major versions of PHP. We want to ensure that we will work on it, even if we are not yet there. Which means, for example, we have projects written for PHP 5 and 7. Still, there are cases like that. And on production, we need support PHP 5 for it. But we have in mind that soon we're going to switch to PHP 7. So let's already be ready for it. Let's write the code in a way that it will also compile on version 7. Great example for it. With CS Fixer, we can apply the migration for PHP 7.1 or whatever we're going to target, and it will, for example, add strict types. So if we had our code base without strict types, running properly on PHP 5, if we would add strict types, it would not compile. So we just do it on the fly, on CI level, that if somebody misuses the types, it will fail on a CI level. Next lesson. Check missing dependencies. It's often not just for the libraries, but it's often also for the PHP engine itself. Most popular case is that we are using some JSON functionality, but we are not saying that we are depending on the JSON extension. There are cases when we can install PHP without JSON extension. There are Docker images without it. So if our project doesn't explicitly say we depend on it, we wouldn't know. So let's explicitly say in our composer JSON what extensions we need to have, what libraries we need to have, and let's check it with composer required checker, so we maintain it properly. We know that if somebody added new component, it's explicitly listed as our dependency. Next lesson. As we are next to composer, let's always have the composer look similar, so it's easier to read it, easier to maintain it if it always looks the same. So we can call composer normalize plugin here in dry run mode, so it will normalize JSON prettifying and order of configuration. Finally, after we tested, verified, auto-review the environment and the configuration, we can start auto-reviewing our code. We can do it actually as a test. I used a PHP unit for it, so basically we are extending PHP unit test case with our auto-review class. We explicitly say that it doesn't cover anything, so even if it would run the code, we don't consider it valid for code coverage. We set the grouping so we can filter it in, so we can run only it, just in one job instead of on every single job matrix, or we can say that we don't run it for code coverage as well, so the execution will be faster. What we can do here? Some examples from PHP CS Fixer. One thing for PHP CS Fixer, we have different rules. We have over 200 rules currently. So we wanted to somehow standardize how the rules are described. So basically, we said that each rule should have a description written as a proper sentence, starting uppercase, ending with a dot. If we refer to some common terminology like PHP talk or PHP unit, it should always be written in the very same way. If we wanna have, if we have the definition of the rule, we have code samples. It's an array, but we also want that array to not be empty. So every single rule is required to contain some examples. Without any of those, the unit tests for given fixer, for given rule, are still working. Everything is written according to book, every interface is properly implemented. This is just some addition to it, on top of it, to ensure the quality of documentation. We can either manually ask every single person for every single rule to do it similar to another rules, or we can enforce it globally. Other example is we can ensure the branching model. If we say that we have the main branch, master branch, it should always contain the branch alias, and the branch alias should be matching with application version itself. During the branching merging, when we release, it's super easy to forget. So let's automate. If somebody forgot, the test will fail. Next one, again, just a standard preset. When we have the commands like help command, fix command, describe command, we set up a rule that we have the name of it as a class constant. We cannot make it as interface because it's just a constant. We don't want to make it as abstract method because we don't want to introduce our own command class. So we just have a test to ensure we have it normalized. Next one, kind of funny one. Once in a while, we have PRs that are not just touching 2 files. We can have a PR that touch 20 classes. Sometimes it introduces 10 new classes. And when it's a bit bigger, it's super easy to oversee that some of the classes may actually not have tests for it. So let's ensure that every single class has a test. Other examples, we can basically make anything we want to do. It's just a code. So we can have a test that we don't expose properties. We decided that if we want to expose something, we do it with method. We decided that every single test should be marked as internal because nobody is supposed to extend it. We decided that we don't want to abuse interface, which means if you have a concrete class, it should create only methods that are defined by interface. You should not add 10 more methods that are not defined by interface, and so and so. Next lesson. As we are already touching the code, we can start having some smoke tests as well, and we can still use PHP unit for that. Does anyone know what are smoke tests? Okay, a few of us. Basically, super first glance view on the build application. Does it look to work properly or not? We don't want to test every single feature. We don't want to execute every single test. We just want to make super short view. Does it look to be working properly or not? Without going that much into details. It's super not common test to be executed on CI. Basically, often we have a scenario that we run on all the tests, everything works, so we trigger a release or deployment, and then on that build, something failed. So we know that every single unit test, integration test, whatever works, we try to build, then it crashed. For a CLI application, when it's installed via Composer, we actually, a deployment for us is just making a tag. So we want to check that after creating a tag, our application would work. We can install it. So there are two parts. We want to install it. So we install it with Composer. We ensure that autoloader works, because maybe autoloader doesn't see everything it's supposed to see. And then we check, can we actually run commands like the version and fixing itself. Other set of commands are to prepare artifact. Basically, Composer can install our package, our application, our repository, both ways. It can either clone the repository or download the archive file. So we have both scenarios prepared. Then we just run the script, run the commands in temp folder. We see does it work properly, or maybe the fixing command will fail. Next to Composer, we release a far file, so everything in once, every single file in one executable. And once we fail that not every single class that's required was packed into far file because of configuration and how we build far. So we also want to ensure that after building a far file, we can fix something and we can actually call for a help. So two most crucial commands for us are working properly. Lesson 9. It's not only about PHP. Actually, it's not only about code. We can run some basic small tests for any file we want. But here we decided to check if any file contains trailing spaces. Doesn't matter, is it PHP, README, MD, whatever. We just don't wanna have trailing spaces. We wrote it as a shell script. We actually extracted it even to dedicated repo, so we can call it from anywhere. And then if something is failed, nice reporting. That leads us to final lesson. We don't need to be fancy. What it means, we don't need to wait for proper tooling for us. If there is no static code analysis tool that checks what we need, we don't need to wait for it. If we don't have let's say PHP unit or whatever framework that we can utilize to write our logic, we don't need to install it only for having it. We can write super dummy, super small, super simple checks as a simple git grabs or regexes or whatever, put it in the shell file, and we can check whatever we were asking frequently in our code reviews. Here it's an example of totally different project. It's actually a front-end project. We wrote in Angular, in TypeScript. Sometimes people were contributing and adding JavaScript files. But we want to have TypeScript, we want to have types, so we automate asking them, hey, write it as TypeScript instead. Super simple check. We just check the extension. We run it on every job. We don't need to remember about it. We don't need to ask people. We automate it. And those would be all the lessons, how we can automate review to make it a bit smoother, a bit faster, to let us focus on the real code change, on the real logic that the contributor is willing to do, instead of all the details around. If you have any questions, please ask now, maybe after the presentation, if you don't like to do it in public. Is there something?
Any questions?
Yeah, try me.
A stupid question is this. Under what circumstance do you use a FAR file? Because I've never seen them used. I've seen them downloaded.
Mm-hmm.
I've never seen them used. Why would you create one and use it in your deploy process?
Mm-hmm. Our deployment process creates a FAR file, and we provide that FAR file for our users. Basically, some of the users don't want to install our project PHP CS Fixer as dependency over Composer because of conflicts in dependencies. For example, we require, let's say, Symfony console version 3 something or 4 something, and the guy is still on version 2. He cannot update. It's super hard for him. And instead of forcing him to update his whole project, we just created a FAR file with all dependencies encapsulated so he can just execute.
Okay, that's great. Now I know why you use them.
Most of the people still use Composer. I also use Composer for dev dependencies, like for all the toolings. Sometimes it's hard to do it.
Okay, another question? We have time, so feel free.
Don't be shy. Okay, cool. Then thank you for your attention. As I said, you can always catch up with me later. You can write me on a mail or ask something on Joindy. Don't hesitate to comment as well. Thank you very much.